Morning. So today is kind of a fun day. It's Unit 13, Day 12. It's just fun to say, called Sinusoidal Modeling. So all that actually means is that anything that kind of does that like wavy action, like up and down. I know you can't totally see my hand the way I want you to, but anything that's periodic, basically. So where it keeps repeating, right? Or sinusoidal. All right, so that's cosine or sine. Keep that in mind. So when you think like light, we talk about like the tides are going to be some of the examples. You could even pretend maybe like a little roller coaster that goes up and down. Anything that does that type of pattern, you can model it using a sine or cosine curve for at least a particular period of time. All right. So as a quick reminder, all of this is listed on the sheet for you, which is kind of nice. The amplitude, frequency, how to calculate the period, phase shift, if there is one, and the midline. Now, I'm not going to fib. We are going to try to avoid the phase shift as best we can. Kind of like it's like coronavirus. I know, probably too soon for that joke, but we're going to try to avoid it. So come on down here. It says right here, phase shift, we're going to keep it 0, which means we're going to solve for what's the amplitude, what's the frequency, and then what's the vertical shift, or what's the midline, essentially. But here's the cool part. You have to read the question, and you got to be able to draw a sketch. Then we're going to create an equation from that. So I'm trying to figure out, every day it's a daily struggle how not to be crooked while you're watching the video. Okay, so reading through it, it says the tides in a particular bay can be modeled with an equation in the form of A, cosine of B times T, and then plus C. Don't let the C throw you. If it's plus on the outside, that is the midline we're talking about. T represents the number of hours since high tide. D represents the actual depth of the water in the bay. The maximum depth of the water is 36 feet. Minimum depth is 22 feet. And high tide hits every 12. Actually, when I was in Florida over break, we were in a spot where you could see the water level fall and rise as the tide came in and out. It was kind of cool. And yes, it actually made me think of these problems. There you go. All right. So what that means along the bottom, this is the time that passes. All right. And then along the side, we're talking about the depth of the water. Mm-hmm. Now it's saying that, let's see, look at the relevant information. The maximum depth goes to 36 feet, the minimum 22 feet. So on that left side, don't worry about it being perfectly like spaced out. But basically what we care about is we have to look at a minimum of 22 and a maximum of 36. Those are definitely numbers we want to focus on. All right? The high tide hits every 12 hours. All right? But it says on the axes, sketch a graph for the scenario for 2 full periods. So if it hits every 12 hours, periods, 2-hour time period. So it needs to go from 0 and then over here to 24. So it's really important to get the scaling down first, just like we did in that little practice video. Mark the halfway point, that's 12, and then mark the halfway points between those. So 6, 18. It says label the axes and the points on the curve representing high tide and low tide. Cool. Okay. So let's see if we can actually sketch this thing out a little bit. It says that T represents the number of hours since high tide. So that means at T equals 0, we have to be at high tide, which means the depth is going to be at that maximum of 36 feet. All right. So that means at time 0, that's where we're at. And it says high tide hits every 12 hours. So go to the 12-hour mark. We should be right back at high tide. And then we can play that game again. Go to the 24-hour mark. We should be right back up at the highest depth of water, 36 feet, right? It tells you, it follows a little bit of a cosine curve. But the idea is that high tide, water drops down. At low tide, comes back up. So because it's symmetrical, low tide then should be happening at the 6-hour mark. So 22. All right, and then I can do the same thing for that second cycle. When is it going to be at the midline point? Well, at the halfway marks in between there. So if you'd like to, you can put little tick marks at 3 hours and 9 hours. And then again over here at 15 and at 21. Right? And now what is that midline? Well, let's actually calculate it. So the C value, or the midline, needs to be the average between the max and the min here. So if we do 22 plus 36 and divide it by 2, right? 22 and 36 is going to give me 58. That's going to come out at 29. So right here, we can mark 29 and go ahead and draw in that dotted line. And it's important because that's where it's going to hit in between those high and low tides. So at the 3-hour mark, it should hit the midline. At the 9-hour mark, hits. At 15, at 21. Now you've got all your anchor points, if you will. You can nicely sketch in that curve. So make it as pretty as you can, hitting all the points as you go. So this is representing the depth of the water over time here. So we've got our midline. That was at 29 right there. Now that we've got the graph, we can answer everything else. What's the amplitude, or the A value? Well, the amplitude is that distance from the highest point to the midline. That's your amplitude right there. So that's just going to be the difference from 36 to 29, or you could do 29 minus 22. I don't care which way you look at it, but the amplitude there comes out to be 7. All right. The B value, or the frequency. This one you might have to do a little bit of work to figure out because we're not scaling it from 0 to 2 pi. So instead, what we can look at is what's the period of this graph. So I see one full cycle from 0 to 12, which means 12 hours. So if the period is actually equal to 12, let's set 2 pi over b equal to that, and we can solve for b. So I'm going to throw it over 1, do a quick little cross multiplication. So 12b equals 2 pi. Divide both sides by 12, and then simplify. B is going to come out to be pi over 6. Keep it exact. It'll make things easier. So pi over 6 is going to be my value right there. So now when it's saying, all right, determine the values of A, B, and C, we did that. Verify your answers and your sketch on your calculator. Well, we have to have something to type into the calculator. So let's write ourselves an actual equation. So based on this, we can use y and x, or we can use d and t. It doesn't actually matter, right? Maybe I'll write it both ways. So it's going to be y equals 7 times the cosine of, in for b is going to go pi over 6 x, and then plus that midline of 29, right? Or I could put d here, and then I could put t here. Either way. All right, let's see if we are correct by doing a few things. Into your y equals. Let's actually type in the equation. So anything that was in there, get rid of it. You know the drill. So 7, and then cosine of pi over 6 x, close it up, plus 29. I actually think it's helpful to draw the line y equals 29. It just kind of grounds it to see that midline in there. The last thing is I have to change the window. So look at the scaling that we gave ourselves here. We're graphing it from 0 to 24 on the x-axis. So no more crazy scales there, which means I'm going to have the tick marks go every 3 units the way I've got it right here. And then on the y-axis, I'm still going to go down to 0, but then up to 36 so that I can kind of see what's going on here. All right, hit graph. You should already be in radian mode. If it doesn't work, double check and make sure you are in radian mode. So there's our 2 cycles. There's the midline. There's our perfect cosine curve. We're so smart. All right. There's one last part to this question. It says tinker boats cannot be in the bay when the depth of the water is less or equal to 25 feet. All right, because if there's not enough depth, they're just going to ground out at the bottom there. So it says set up an inequality and solve it graphically to determine all the points in time t over that interval when the tankers can't be in the bay. Right? So we're saying that this 7 cosine of pi over 6x plus 29, we want to know when it's less than or equal to a height of 25. Right? And if you look, the height goes anywhere from 22 to 36. So we're kind of looking at like, when is it down here? Maybe I'll grab a different color. At 25. So we can kind of estimate the answer. It looks like anywhere between, I don't know, somewhere between 3 and 6 hours, and then 6 and 9 hours that they won't be allowed in the bay. And then that would repeat again over here. If I want to make it a little bit more exact, though, than my estimation, I'm going to come back up here, and in my y equals, instead of putting in the 29, I'm going to actually get rid of that, and let's put in the 25 here. And so now when I graph it, that red line that I just sketched over here is now going to be the line that we see on the calculator. Hopefully we haven't forgotten all our calculator skills. If we want those intersections, we're going to do second, and then trace, oops, and then intersect. So give it a shot. Second, trace, intersect is trace 5, and then slide it on over. Whew, all the way over here. There we go. Enter, enter, enter. So I got about 4.16, or let's say about 4.2 at the first intersection. And then I'm going to do this just one more time to calculate the little intersection next to it in that first cycle. So that second intersection comes out about 7.83. So let's say 7.4. All right. So what that means, those are time values. So I'm going to say from about 4.2 hours to 7.4 hours after high tide, there can be no boats, right? In the bay. Otherwise, they're going to hit the bottom, and that's not good. Right? Now, can you come over here and calculate the other two? Sure. But think about what this means. If the period of the graph is 12 hours, that means it's going to happen again 12 hours later. So if I had 12 hours onto 4.2, that would bring me up to 16.2 hours. If I had 12 hours onto 7.4, that would bring me up to 19.4 hours. So it's going to happen anywhere between these two time frames, anywhere between those. So if we pretend that this start time is, I don't know, midnight, then this would be between 4 and 7 a.m. And then this would be between 4 and 7 p.m., essentially, is what you're looking at. Right? I don't actually know what time that corresponds to, but it's the idea that we understand how to use it to answer the question. All right, that's it for the first one. As for the other ones, let's see. I do want to look at probably examples 2 and 3. Maybe we'll skip example 4. Okay, so back here, example 2, you're not required to graph it. You're expected to be able to kind of deconstruct what you're being given to find the answers that you need. So for example 2, it says the height of a yo-yo above the ground can be modeled using this equation. So they're giving us the equation. Thank you. Where h represents the height of the yo-yo in feet above the ground, t represents the time in seconds since the yo-yo is first dropped. Make sure that you recognize what's going on. H is the height of the yo-yo, right? And then t represents the time since the yo-yo was first dropped. And we can kind of picture that a yo-yo would go like down and up and down and up. So it makes sense that it would fit this model. It even makes sense that it's cosine because it starts high and then you drop it down, comes back up. Drop it down, comes back up. That's exactly what a cosine curve does. So when it says determine the maximum and minimum heights that the yo-yo reaches above the ground, right? Think about, all right, it's going to go up and down. Don't mind my awesome drawing. But what's the max it's going to hit? What's the minimum it's going to hit? Right? So think of the values that you need to be able to answer that. I need to know where's the midline? And then how far up and down does it go? Well, you have to add and subtract that distance right there, which is known as the amplitude. Right? So your midline, 2.25, and then plus or minus that amplitude of 1.75. So if I subtract it, it'll bring me down to a height of a half a foot. If I add it, it's going to bring me up to a height of 4 feet. So that's your minimum and maximum heights that it reaches. If you want to write it as like a range, feel free. That's up to you. Right? But that's essentially what the question is asking you for, is what is the range of values here? All right, how much time does it take for the yo-yo to return to the maximum height for the first time? So you take it, you drop it down, you come all the way back up. It's asking you how much time did that take? Time is the x-axis here. So I want to know, what is that length? Well, that length is referred to as the period. So the period is 2 pi divided by the b value. So in my equation, that's my b value right there. So if I do 2 pi and divide it by pi, that's actually pretty nice. I don't even need a calculator. I just come out with 2. So think about the unit of time. Time in seconds. So it takes 2 seconds to drop the yo-yo down and come all the way back up. I am terrible at doing yo-yos. I was never good at it. But technically, that's what they're saying here. Okay, last question. I want to do this one because I think it's helpful to see one more word problem with drawing the graphs. If you think you're okay after looking at that first word problem, maybe you can stop the video here. Otherwise, just keep watching. Okay? So last one is talking about a Ferris wheel. It's saying it's constructed such that a person gets on the wheel at the lowest point. That makes sense. 5 feet above the ground. So the lowest point. So maybe there's like little stairs to get on. I don't think they make you run and jump. All right. It reaches the highest point at 130 feet above the ground. That's good to know. The amount of time it takes to complete one full rotation is equal to 8 minutes. That seems excessive to me, but maybe it goes either really slow or I don't know, it stops or something, but don't overthink it. Okay. Person's vertical position can be modeled as a function of time in minutes. So their vertical position, y, is modeled as a function of time in minutes this time. So not seconds, minutes. And they're using t for that. And the equation is given in this format. All right, so here's where we're going to create the equation. So sketch the graph, which I do think is important to do first, and then take it from there. So if we're going to sketch it, we need the scaling first. So you have to consider what your scaling is. So the x-axis, we said, represents time, and one full rotation takes 8 minutes. So we're going to go from 0 to 8 here. You already know we're going to need to mark the halfway point at 4, and then the quarter points there at, oops, not 2 and 2, 2 and 6, all right? As for the vertical axis, it says the lowest point is 5 feet, the highest point is 130, all right? 5 feet, so this is the vertical height, and 130 feet. Okay. We're starting at when you get on. So you start at that height of 5 feet, all right? And since it takes 8 minutes to make one full rotation, at the 8-minute mark, you're back down at the bottom at 5 feet, right? It's got to be symmetrical. So from 0 to 8 is the one full cycle. The halfway point, 4 feet, that is when you're hitting that maximum height of 130 feet, right? When do you hit the midline? Well, at the 2 and the 6. So to be able to sketch that correctly, you do have to do a quick calculation. So the midline is the average of the lowest and the highest points. So if we do 135 and divide it by 2, we get 67.5. Yes, it's okay to have a fraction. All right. So right down the middle, that means at the 2-minute mark, I should be right on that midline. At the 6-minute mark, I should be on that midline. Now you've got enough to at least sketch the picture. So that's the height. You're 5 feet off the ground, up to 130 feet, and then back down. All right. In this equation, that's the C value. Now we can go answer the rest of it. The amplitude, that is that distance from the midline to the top or the midline to the absolute bottom, whichever way you'd like to think of it. So you can do 130 minus 67.5 or do 67.5 minus 5. Sometimes it's easier to go midline to the bottom just because the numbers are smaller, right? But you could do 130 minus this, and it would give you the same thing either way. So it comes out to be 62.5. That's the amplitude there, all right? the B value, the frequency. Again, you got to play the game here of calculating the period first, because when it's not just 0 to 2 pi, you can't just look at it and be like, oh, there's 3 cycles. Like, no. So since the period, the length of that one cycle is 8, set that equal to 2 pi over b, play the game, cross multiply, b, divide, reduce. So pi over 4 is the b value, or the frequency here. Okay, that's enough to write our equation now. So I'm going to stick with y, and it looks like they've got t, so I'll try to remind myself that I need to use t here. So it's y equals the amplitude, so 62.5 cosine of frequency, pi over 4, t, if you put an x there, it's okay. All right, and then plus the midline of 67.5. Now, if we go and graph it, you have to make sure and change your window so that everything looks okay. So I'm going to type it in first. So 62.5 cosine of pi over 4 x, and then plus 67.5. I am going to type in the midline because I think it's just helpful to see that the graph looks appropriate. Now I'm going to change my window. I only want to see from 0 to 8 this time with tick marks every 2. And then my heights, I'm going to go from 0 all the way to 130. All right. Ooh, it's not checking out quite right. It fits the screen beautifully, but it's upside down. So graphing sometimes helps us catch those little mistakes to get it to flip over. That's the last detail you need. It needs to be negative. So if it's an upside down cosine curve, you need that negative to get it to flip upside down. All right. Thanks for watching, guys. Good luck with the homework. I have a session on Friday that we can meet, and also a session on Monday. If either of those don't work for you, reach out to me and let me know.